This is a CPU. Its purpose is to fetch, decode, and execute instructions. These are called FDE cycles, and modern CPUs do billions of these per second. That's a frequency, so we measure it in hertz. CPUs are packed with components all working together. I'm going to show you a visual representation of it working in Minecraft. This is a CPU, well, a very simple diagram of it. I will start with the fetch. So what happens is in the program counter, we'll read the value. This was 0000, and this holds the next address in memory. So it always points to that. This is copied to the MAR. So this is now also 0000. And going through the address bus, which is unidirectional, we end up in RAM. And we check for the corresponding address for the data. So here it was 000, so this checks out, so we're checking this. And this is the data. Now this data is copied through the data bus, which is bidirectional, so it can go this way or it can go this way, as you wish, into the MDR. Now the MDR is the memory data register, which makes sense. You can remember MAR as address register, MDR as data register, and the data is copied over here. Data from the MDR is then copied to the CIR, which is the current instruction register. And finally, the program counter is incremented by 1 to indicate the fetch stage of the Fetch-Decode-Execute cycle is complete. Quick side note, we wait for the control unit over here to send a read signal, which allows you to check the data for the corresponding address. And that is the fetch cycle complete. Now we go on to the decode bit. The decode bit is completely used in just the decode unit. So what does the decode unit actually do? It checks what's in the current instruction register, which we currently know is whatever that is, right? And here we have, so the first bit is the opcode, and the second bit is the operand. The opcode is what to do, and the operand is what to do it to. So for here we have 0101, which means load, and 0101, which means load into the address of 0101. Now the control unit knows what to do, and that is the entire decode stage. It's just figuring out what on earth is inside the CIR. Now we can move on to execute. So since we know that was load the contents of whatever is in the address of 0101, we'll go from the thing, we'll go to the MAR, skip program counter, and we'll go into the MAR and we'll update this to be 0101. Now we'll go into RAM after waiting for a read signal. We'll go into 0101 and we have this. So what we do, we copy this data. Oh yeah, we're not checking this anymore, are we? Take this data and we load it into the MDR. But unlike the FDE cycle, we're going to load this into the accumulator. So now this was updated to 0011. This is copied to the accumulator. And yeah, if you continue this entire program, you'll see that all it does is add 3 in 1, and you can check that out yourself. And that is actually the entire fetch, decode, execute cycle. There is a little bit more to it. There's something called program branching, which is when we set the program counter. For example, like in an if statement where we want to jump a few lines in code, we would set this directly to this, which is not the next one. So it would skip ahead in the program to another line, and this would happen due to the CIR having the correct operand, which I believe is that. But of course not all CPUs are built the same. There are 3 ways to improve the performance of a CPU. First one is obviously to increase the clock speed, so i.e. make the frequency higher, give it more gigahertz. The next thing is to increase the cache. Now there was cache in the video if you didn't see, but all caches is just stores the most recent result instead of having to go all the way into memory. And the third and final way is to add more cores, which allows you to do more parallel tasks at the same time. This may not work in all programs, however, because some programs such as the Fibonacci sequence require the result from the previous calculation, and therefore you cannot make the program parallelizable.